Today we're going to focus on porting a 3JS project into webxr. So the project we're going to use is Simondev's Star Things. This is a nice project to get started on because it's very well laid out. There's also a YouTube tutorial to go along with it, so if I ever get lost, I can kind of refer back to that. But mostly it is just coded quite well. So it works great out of the box on desktop, but if you try loading it up on mobile, it crashes immediately. I had to work out what that problem was, and in doing so, I basically just removed components until it started working. So to start off with, I got rid of all of the enemies, and I got rid of a lot of the extra UI, and once I stripped it down, I got something that was functional, although nothing was to scale. So the scale of this game is basically the actual size, whereas if we do this in webxr, we need to scale it down quite a bit. So we're going to go with a 1 in 100 scale. So we're going to scale everything down by a factor of 100. The code is broken down into a bunch of different JavaScript modules. It all has main as kind of the central module, and that activates a bunch of other modules. And so in particular, the ones that we're going to want to focus on is the spatial hash map, the spawners, and everything that comes from the spawners. And those are the main things that we are going to have to scale down. So basically, wherever we see an 100, we put a 1. Wherever we see a 1, we put a 0.01. And that's basically how we go about doing that. Once we have the scaling done, there's a few extra changes we need to make. We need to add in some extra UI changes so that it works on mobile, and then we need to add in path changes for the particular server that we are going to be using, which is Django. So now that we've stripped everything away and removed the third-person camera as well, it is functioning in webxr. We can use our module and we can get it working, but there are still quite a few things that were not functioning quite the way you'd expect. So in particular, a lot of the lighting seemed a little bit off, and the lasers and things were going from the wrong direction, so we had to change some positioning thing. But those were just some extra modifications that I missed the first time around. While doing the scaling, I also increased the lighting effects because a lot of them are less visible in fully lit scenes. So it might look a little bit weird now in a digital environment where there's black everywhere, but it looks a lot better in a real world situation where you actually see some of the flashes happen. Once I had the player functioning, I managed to be able to load in 5 of the enemies. It was pretty capped out in terms of performance, so I don't think you can get too much more out of that unless you kind of take away some things. The AI is a little messy, although it actually worked pretty well for the game. It kind of has a scaling aspect. So the enemies kind of form a sphere around you, and then as you chase them down, the one that's behind you tends to fire at you. So it kind of has some aspect where it does feel like you're playing against someone. And then the last 2 enemies are actually kind of challenging because they tend to line up. And so one of them tends to get really good shots on you. It's kind of a fun game. It has a pretty good difficulty curve as it gets harder as you have fewer and fewer enemies, which is kind of a neat thing. Right now we have gotten the base game functioning, and what I would like to do is add in some features from AR. So the 4 that I was thinking about is light estimation, so being able to calculate out the light around in the real world and then putting that into our scene. Then I wanted to think about using depth, so using depth for shadows, so being able to cast shadows from our 3D models into the world. So we'll need to kind of create an invisible model of the world and then project onto that. The next thing is depth occlusion. So I was thinking about using depth to occlude objects or occlude planes that are too far away, and then depth collision. And so with these 4 ideas, I just wanted to go over the fact that some of these are going to be a lot more possible, and it's going to be hard to implement these all at once. So it's probably going to be implementing them all separately, and then maybe we can get them functioning if we use some tricks. But that's going to be left for a later date.